So part 2, we're going to combine these restrictive maps into one whole restriction map. So how do you do that? We have an information about combined enzyme right here. So we're gonna we're gonna combine the numbers and then try to find where it is placed and add up, subtract, and try to make one whole restriction and map. So we start with this. So there's no certain way to do it. Like there's no equation. So we have to just think about where.
We're kind of just guessing and checking. Really.
So we're gonna start with this one. So here's the smallest fragment of HIN3, which is also in the combination of HIN3 and BAMH1 and HIN3 and EcoR1. So we can tell that the smallest fragments are not interrupted by BAM3, BAMH1, and EcoR1. So we're just gonna move this thing right here. And here's our HIN.
Yeah, so we know that when looking at HIN3 and BAMH1, another similar fragment was the 2.35 kilobases. So we knew that when this was cut, that size of the fragment, as you can see here, would still remain the same. So when we added our cuts, we are going to put, we're going to transfer basically this cut, and we're going to put one here,
one here,
and one here, so that we know after combining these two that we have our 1.65 kilobase segment and our 2.35 kilobase segment. And when you look at these, you have a 0.27 kilobase fragment and a 1.2, which, as you can see here, here's the 2.7 kilobase fragment, and here is the 1.20 kilobase fragment. So we have all four. We have the 2.35, the 1.2, the 0.27 kilobase pair, and the 0.18 kilobase, which adds up to 4.
And if you didn't use HIN3, this whole thing would be the same as 1.65 kilobase right here.
Mm-hmm.
And lastly, we're gonna combine EcoR1 into this map. So we know that there's 1 kilobase and 3 kilobase segments, and here's two combinations with EcoR1. So we're gonna use the last combination, and we can tell that forget that.
You
Forget
can
about
use
that.
either one, but
yeah,
sometimes one is easier than the other. It's all based on your preference.
So we're going to use the second to the last one because we already know that where this 0.18 kilobase is located at. So it's right here. And we're going to find where 1.87 kilobase and 0.95 kilobase is at. We know that EcoR1 has one long kilobase that is contained here, contained in both only EcoR1 and combination of.
So we know that when this is added to the plasmid, that cut is going to not be affected by other restriction enzymes.
But because we need one long kilobase here, we're just gonna flip this and then make this one be 1.00 kilobase, and these two will be EcoR1 restrictive site.
So after we place those cuts on this plasmid, where are the other cuts located?
So we're just gonna calculate and check if we did it right. So if we for example, if you use this as an this combination as our proof,
If this is the one that we used to put in the cuts, if this is how we used it to explain what we were doing.
so because we cannot eco R1 restrictive site is after BAMH1 restrictive site, we cannot use 0.95 kilobase right here because there's already 1.20 kilobase. So we're gonna assume that this long segment is 1.87 kilobase long, and if you subtract 1.20 kilobase, this will be 0.767 kilobase. And then this should be 0.95 kilobase, so when we subtract 0.27 kilobase, it will be, give me a second, 0.68 kilobase. And this is our entire restrictive map
For the plasmid of PDA
401. And then if we add up the
if we add up each kilobase segment, it all totals to 4 kilobases.
And you can always check your work with comparing with the combinations here. And
thank you.